Hi students, welcome to my channel Maths Classes 7-8 CBSE by GK Pillai. Another very useful channel for class 10th students by name Maths Classes 10th CBSE by GK Pillai is already available on YouTube. Please convey this message to any of your friends in class 10th anywhere in India. This video is on the chapter Squares and Cubes of class 8. As I have already stated, my videos are based on the latest syllabus and textbooks from 2025-26. You will find in this video the fundamentals of the chapter, questions from the textbook, and some practice questions explained clearly. Questions involving construction will not be finding a place in this video. We'll try to include them also in my next video. Subscribe to my channel and share the videos to your friends without fail. Square of a number. A number obtained by multiplying a number by itself is called a square number or simply a square. You must be knowing about these things. If you write 5 into 5, it will be 5 squared, or that is equal to 25, and so on. In general, if you take any natural number n, maybe 11, 11 into 11 will be 11 squared. Now, a number is a perfect square if its prime factors can be split into two identical groups. For example, 36, I am prime factorizing it. You should know about the prime factorization of a number. If a number is ending with an even number, it will be divisible by 2. Again, this is a number ending with an even number divided by 2. Another 3, next 3. You should know the divisibility rules. Any even number will be divisible by 2. A number whose digits when added, if it is divisible by 3, then the number will be divisible by 3 and so on. So you should know the divisibility rules definitely for doing this chapter. Now, a number is a perfect square if its prime factors can be split into two identical groups. The prime factors of 36 I have divided into two identical groups, 2 into 3, 2 into 3. Therefore, the square root of 36 will be 6. Let me explain further with the help of an example. Is 156 a perfect square? The prime factorization of 156 will give you 2 into 2 into 3 into 13. Here, 2 and 2 make a pair, but 3 and 13 are not paired. Therefore, 156 cannot be a perfect square. This 156 can be made into a perfect square by multiplying this by 3 and 13 or 39. Another one, find whether 2800 is a perfect square number. Sometimes you will be able to decide whether it is a perfect square number by looking into it, looking at the number. By looking at this number, we can decide whether it is a perfect square number or not. But when answering an examination question, we cannot easily do so. But if it is an MCQ question, you will be able to. I'll explain what it is. 28 is not a perfect square number. So the whole thing, this is not a perfect square number. If it was 25 instead of 28, this is a perfect square number. But if it is a normal question, you should be able to write like this. By factorization, 2800 becomes 2 into 2 into 2 into 2 into 5 into 5 into 7. 7 is missing. One more 7 should be there. So 2800 cannot be a perfect square. And if you multiply 2800 by 7, the new number will be a perfect square. Now, what are the properties of perfect square numbers? Here, I am giving everywhere examples. All perfect square numbers end with the digits 0, 1, 4, 5, 6 or 9. It cannot end with a number 7. It cannot end with a number 3. It cannot end with a number 8, and so on. I'm giving examples here. 10 squared is 100, 21 squared is 441, 12 squared is 144, 15 squared 225, and so on. So here I am explaining that a perfect square number cannot end with the digits 2, 3, 7, and 8. The third point is square of a number will have double the number of zeros of the original number. If you are to find the square of 200, the square of that number will have 4 zeros. Squares can only have an even number of zeros at the end. I am giving examples here. 900, it will be 81 and 4 zeros. 2000, the square of 2 you will write first 4, and there will be 6 zeros. And another two properties here. If a number has 1 or 9 in the units place, then its square ends with 1. And another one, if a number has 4 or 6 in the units place, then its square ends in the digit 6. These are not very important, but still you should know. There are certain patterns and properties of perfect square numbers. These are all there in the present textbook. It was there in the previous textbook also. So let it be explained here also. Difference between consecutive squares gives an odd number. 4 and 1 are consecutive squares. 9 and 4 are consecutive squares. And 16, 9 are consecutive squares only. And the difference gives you 3, 5, 7 and 9. So the difference between consecutive squares give an odd number. The next one, adding consecutive odd numbers starting from 1 gives consecutive square numbers. This is a very important one, very important one. Two odd numbers, consecutive odd numbers we are adding, we are getting 4. 4 is a perfect square number. 3, 1 plus 3 plus 5, 9, which is a perfect square number. Square of 3, because there are 3 numbers and the square of these 3 numbers is 9. Another, 1 plus 3 plus 5 plus 7, there are 4 odd numbers from 1. So here you are getting 16, which is a square of 16, square of 4. Similarly, you will get all these things. So they are very important one. The sum of the first n odd numbers is n squared. So if you are adding 7 odd numbers, the total will be 7 squared, that will be 49. Every square is the sum of successive odd numbers starting from 1. That's what we have done here. Based on whatever we have discussed just now, we can find out whether a number is a perfect square by successively subtracting odd numbers. There is another method. Normally we don't use this method. If you are asked to do this way, then only you do it. Otherwise, normally we do by prime factorization only. The way I have just discussed just before this sum. If we successively subtract 1, 3, 5, etc. from 25 until you get 0, we get like this. 25 minus 1, 24, 24 minus 3, 21, and this 21 minus 5, 16, 16 minus the next odd number, 7, you get 9, and the next odd number, 9, 9 minus 9 is 0. We have subtracted odd numbers 1, 2, 3, 4 and 5 times. So 25 can be written as 5 squared. 25 is nothing but 1 plus 3 plus 5 plus 7 plus 9, 5 odd numbers. Now here a natural number is not a perfect square if it cannot be expressed as a sum of successive odd natural numbers starting from 1. This you should definitely understand. The new book is giving importance to this kind of things. Now another one, this is another pattern given in your textbook and also in the previous textbook. 1 squared plus 2 squared plus 2 squared is 3 squared. 1 into 2 is 2 here. And the next number 3, the square is here. I'll tell you from the next one. 2 squared plus 3 squared will be 2 into 3, 6 squared. And when you add all the 3, you will get the next number 7 squared. One more I'll tell you. 3 squared plus 4 squared will be 3 into 4, 12 squared. And the next it will be equal to 13 squared. Here, if it comes as a fill in the blanks, here it will be 4 into 5, 20, 20 squared. And the next will be, it will be equal to 21 squared. Now square root of a number. If you are having a square number, naturally you will be able to find the square root of this also. In your day-to-day life, many a time you will be using square root of a number. For an example, suppose you are having a square plot of area 100 centimeter squared. 100 meter squared. If you want to find the side of the square, naturally you will find the square root of that only. So it will be always good to remember the square root of a number. Definition goes this way. Square root is the inverse operation of square. In general, if y equal to x squared, then x is the square root of y. Don't mix up this. We know that 5 into 5 is 25. Also, minus 5 into minus 5 is also 25. So, 5 squared is also 25. Minus 5 square is also 25. So, if you are going back, if you are going for the inverse operation, the square root of 25 will be plus 5 as well as minus 5. You will do such things in your higher classes, even after your 10th standard. At some places you will have to use plus 5 as well as minus 5 while finding the square root of 25. But as far as you are concerned now, in this chapter, in this class, you will be using only plus 5 as the square root of 25. Every perfect square has two integer square roots. One is positive and the other is negative. So square root of 25 will be plus minus 5. Similarly this. In this chapter and this class, you shall only consider the positive square root. Square root of 100 will be 10. The two questions which I am going to discuss with you now are useful to you in one way or the other. This question can come as it is. Otherwise, if you are asked to find the square root of a number, we normally do by prime factorization. If you are asked to do this way, then you have to do this way. Find the square root of 100 by the method of repeated subtraction or repeated subtraction of odd numbers. You keep on subtracting odd numbers from 1, 3, 5 and so on. So 100 minus 1, 99. So 99 you subtract 3 equal to 96. Then you subtract 5 and so on. Ultimately we are getting 19 minus 19, that is 0. So you have subtracted consecutive odd numbers 10 times. Therefore the square root of 100 will be 10. Here finding the square root of these two by the division method. Division method is not there in your present textbook. It was there earlier, and this is definitely useful to you in many ways. In your future classes, maybe in your 10th standard, 9th standard, suppose you are doing a mensuration sum, you have to find the square root of a number. Instead of going for repeated subtraction or by the method of prime factorization, it may be tedious or it may be long. But if you understand this, if you learn this, practice some more sums, it will be definitely useful throughout your life. Let me explain you this. 729, you have to find the square root. If there are 3 digits, separate the first one and the other 2. If there are 5 digits, separate the one, then the remaining make it into pairs. Here 1296, you have to pair 12 separately and 96 separate. Let me explain you. Now for the first digit, you have to say the table. 2 2s are 4, 3 3s are 9. So we will write 4 here. So 2 2s are 4, 2 you write here, 7 minus 4 you subtract 3. Now you bring 29 down. Now what you do, multiply this 2 by 2 and write here. You have got 4 here. Now what you do is, you write any number here so that when multiplied by the same number, you should get this. 47 multiplied by 7, you will get 329. So this becomes 0. Now write this 7 here also. 27 will be the square root of 729. When I explain you this one, you should be able to be familiar with this method. As I told you, take 12 as the first pair. 3 3s are 9. 4 4s are 16. So stick to 3. 3 3s are 9. Write 9 here. Subtract, you will get 3 here. Now you bring 96 down. Now what you do? 3 2s are 6 right here. Write another number here. And when multiplied by the same number, 66 into 6, you should get 396. And the remainder is 0. Write this 6 here. 36 is the square root of 1296. You can practice more sums. You will see one more property of square numbers. Between n squared and n plus 1 whole squared, there will be 2n numbers. The question is, how many numbers are there between two consecutive perfect square numbers? Between 100 squared and 101 squared, there will be 2 into 100, 200 numbers are there. That is what is given here. Between n squared and n plus 1 squared. N plus 1 squared is this. There will be 2n numbers, 2 into 100. And one more thing you should know, it is useful further. In a series of natural numbers, the nth odd number can be found using this formula. Suppose you have to find the 15th odd number in a series of natural numbers, 15th odd number. So it will be 2 into 15 minus 1, 30 minus 1, 29. This is going to be useful here also. This is one more question. This is definitely available in your present textbook. May be asked by the school people in an exam. Find 26 squared if you are given 25 squared to be 625. We should remember one thing. 625, the square root of 625 is 25, and 625 is the sum of 25 odd numbers. I am giving an example here. 7 squared is 49. There are 7 odd numbers. So there will be 25 odd numbers. When added, you will get 625. Now, for finding 26 squared, we have to add the 26th odd number with 625. So 26th odd number can be found using this formula, 2n minus 1. 2 into 26 minus 1, that will be 51. So when you just add 51 to 625, you will get the next square number, that will be 26 or 26 squared. It will be 626, which is the 676, which is the square of 26. Here you will find answers to some textbook questions. The first one, find the length of the side of a square whose area is 441 meters squared. We have to just find the square root of 441. that you can do either by prime factorization or straight away finding it. The answer is 21 meter. If it is MCQ, you can write this way, otherwise you have to slightly explain it further with proper steps. How many numbers lie between the squares of the following numbers 99 and 100? This I have already explained. Between the squares of 99 and 100, there will be 99 into 2, 198 numbers will be there. Another one, find the smallest square number that is divisible by each of the following numbers 4, 9 and 10. This is a very important question. It is there in your textbook and the previous textbook also. First we will find the LCM of 4, 9 and 10. We will get 180. 180, what you do? You have to prime factorize and write like this. 2 and 3 are in pairs, 5 is not. So if you multiply 180 by 5, whatever you are going to get will be a perfect square number. That will be the smallest square number divisible by all these numbers. The next one, find the smallest number by which 9408 must be multiplied so that the product is a perfect square. Find the square root of the product. This is a often repeated question. Multiplied or divided. 9408 when factorized, prime factorized, you will get like this. 2, another 2, another 2. These are in pairs. 7 is also in a pair only, but 3 is not. So 9408 must be multiplied by 3 to make it a perfect square. This is the answer number 1. Then 9408 into 3, you will get this, and the square root of this will be 168. Now cube and cube root of numbers. Till now we have seen square and square root of numbers. Here it will be cube and cube root of numbers. A number obtained by multiplying a number by itself 3 times is called a cube. You are given examples here. In general, if you take any number n into n into n will give you the cube of that number or n cube. A number is a perfect cube if its prime factors can be split into 3 identical groups. 216, when you factorize you get like this. We are able to write it into 3 identical groups. That will be 6 into 6 into 6, 6 cube. Now about cube root. This is the symbol to be used. And cube root of 216 will be one of the 3. That will be 6. Let me give you another example for finding the cube root of a number. Cube root of 729. We have prime factorized. We got these factors. We have made it into triplets. There are 2 triplets. So prime factors can be grouped into triplets. And the cube root of 729 will be 1 3 from here and another 3 from here. That will be 9. Now the properties of perfect cubes. Cube of any odd number is odd. Practically if you do and see, you will find it like this. Cube of an even number is even. Cube of a number can end with the digits 0 to 9. It can end with any number out of 0 and 9. Between 0 and 9 you can have any number as the cube of a number. Cube of a single digit may contain maximum of 3 digits. It can be single digit also. Cube of a 2-digit number can have maximum of 6 digits and a minimum of 4 digits. Cube of a 2-digit number. Perfect cubes can be positive or negative. For example, if you are finding the cube of 3, you get 27. Minus 3 cube will be minus 27. So it can be positive or negative. The cube of a single digit number may be a single digit, 2-digit number or 3 digits. The cube of a single digit number may be single digit, 2 digits or 3 digits. Here I am giving two examples regarding cube of a number. Check whether 500 is a perfect cube. We are writing the prime factors like this. 1, 2 is missing here. 2 cannot form a triplet, so 500 cannot be a perfect cube. If you are asked such a question, your answer will be this much only. It may be this way. Is 392 a perfect cube? If not, find the smallest natural number by which this must be multiplied. It can be divided also, so that the product is a perfect cube. Write 392, write the prime factors. Here 7 cannot make a triplet, therefore 392 is not a perfect cube. 392 into 7, this missing 7 will be 2744, which is a perfect cube. Therefore 392 should be multiplied by 7 to make it a perfect cube. This is another sum concerning the cube of a number. Is 1188 a perfect cube? If not, by which smallest natural number should it be divided so that the quotient is a perfect cube? The previous one was for multiplication. 1188 can be prime factorized and write this way. Here the prime numbers 2 and 11 do not appear in the group of 3. Therefore 1188 is not a perfect cube. Now if you divide 1188 by these numbers 2 into 2 into 11, that is 44, then the resulting number will be a perfect cube. Therefore the smallest natural number by which 1188 should be divided to make it a perfect cube will be 44. This 44. And the resulting perfect cube is 1188 divided by 44, that will be 27. You may not be required to straight away divide this by 44. You can take out this one as the answer. 3 into 3 into 3, 27. That will be the perfect cube number you are going to get when you divide this number by this. Now another sum. This is for finding the estimate of a square number. I should have included along with squares, but it is finding a place here. This is very much there in your textbook. That is the reason. 22 squared is 484, you should know. And 23 squared is 529, that also you should know. Now the 500 is closer to 484. Therefore, the approximate value of square root of 500 is 22 and not 23. It's a very simple thing. You don't have to be very concerned. Now, this is the end of my present video. If you find the video useful to you, then press the like button and subscribe to my channel. Also, share my videos to your friends. Another video with the practical questions of the chapter will be added shortly.